Welcome to the video lecture Digital Communication. Today we are going to see in this video lecture second unit waveform coding representation. The topic delta modulation. I am Samantha Pratima, working as assistant professor in RMK CET ECE department. In this video lecture I am going to cover topics introduction to the delta modulation, features, principle, delta modulation transmitter, delta modulation receiver, and its drawbacks as well as applications. So before going to watch this video, you must know what is PCM and differential pulse code modulation. In PCM we have some practical limitations, so those limitations will be overcome here in delta modulation. So here the trade-off is reduced system complexity but increased transmission bandwidth. Here how we will overcome the drawbacks of PCM or differential pulse code modulation means by intentionally oversampling the message signal. Here oversampling is going to take place. We will do intentionally. Delta modulation may therefore can be viewed as dual mode of differential pulse code modulation. It is looks like a dual of differential pulse code modulation. In PCM we will quantize and send a sample itself, so it is looks like conversion from analog to digital. Coming to differential pulse code modulation, the difference between two samples which is very low in amplitude, that difference we will code and transmit. Coming to delta modulation, here what we will do means we will approximate the incoming input signal by a step staircase signal. So let us see the principle of delta modulation. So delta modulation is one bit or two level version of differential pulse code modulation. Here either 1, that is a digital bit 1 or 0 will be used for transmission. So with 1 bit we have two levels, that is 2 power 1 is equal to 2. So either 0 or 1 we will be used to transmit the signal. Next, the input signal x of t is approximated to a step signal, staircase step signal u of t, and the difference between them is quantized into two levels, plus delta or minus delta. How it is having a plus delta value or minus delta means it compares the incoming signal with the step staircase approximated value. If approximated value is less than the original value, then it will increase by plus delta and bit 1 is transmitted. If the approximated value is greater than the incoming input message signal, then it will decrease the step signal by minus delta and 0 is transmitted. Here the step size is fixed. This is what I have explained. So this is this pink color waveform is our information signal, and this staircase step signal is our approximated signal. So here the approximated signal is less than the actual original signal, so bit 1 is transmitted and it got incremented. So likewise it got incremented at each and every point up to here, so bit 1 is transmitted. At this point the original value is less than the staircase step value, so the staircase is reduced by plus minus delta and 0 is transmitted, and here all the staircase value is greater than the original signal, so it is reduced by minus delta as well as a bit 0 is transmitted. So this is working principle and how a bit 1 or bit 0 is transmitted in delta modulation waveform. Next, coming to the features of delta modulation, quantization design is here two level quantization, so it is very easy. Input sequence is much higher than the Nyquist rate, so very low frequency signals, to send the very low frequency signals we can use this delta modulation. And coming to design of modulator and demodulator, very simple. Step size is very small. Bit rate can be decided by the user also, and the implementation, overall implementation is simple. So this is the DM transmitter. So here this is the input sample signal, and it is x cap of NTS is approximated value of this one, and which is we will get from the feedback circuit. So this feedback circuit is having one delay element, it having delay time TS seconds, and this accumulator will supply the approximated value of input signal. So this adder adds the two signals and produce an error E of NTS. E of NTS is equal to X of NTS minus X cap of NTS. So based on E of NTS value, the 1-bit quantizer will produce the quantized signal, and based on quantized signal, the encoder will generate either bit 1 for which the input sample is less than this approximated value, and for bit 0 for input sample is greater than approximated value. So this is a transmitter of delta modulation. And coming to delta modulation receiver, the decoder will receive bit 1 and 0 digital code, and here the accumulator again it is having adder and delay element, which is used to convert it into signal, and that signal will be passed through low pass filter. Low pass filter is used to reconstruct the smoothen the input waveform. That is information. Coming to the drawbacks of delta modulation, it is having a quantization error. One is slope overload distortion and granular noise. These two are the error or distortion or noise present in the delta modulation. And applications of delta modulation, for sending the voice signals through radio or telephone communications, we will prefer delta modulation. And ECG waveform, to store the database of ECG waveform, we will use the delta modulation, and for real-time signal processing also the delta modulation will be most suitable. So this is about delta modulation. I hope you understand very well. It is very simple topic. We have seen in this video lecture introduction, key features, that is delta modulation transmitter, receiver, drawbacks and applications. I hope everyone understood well. Thank you for watching.